Many times we run into situations, real world examples, where we have normal distribution, but not a standard normal distribution. So we can compute probabilities for any normal distribution by converting it to a standard normal distribution. And we do that through the use of this equation, z equals x minus mu divided by the standard deviation. We're going to take a look at the Greer Tire Company problem in our book. And we are told that Greer's engineering group estimates the mean tire mileage at mu equals 36,500. So we'll go ahead and enter that in as our mean. And we are also told that they have a standard deviation at sigma equals 5,000 miles. And we want to know how many tires can be expected to last more than 40,000 miles. So we have an x of 40,000 miles. And as you can see over here, we have a greater than sign. So we want to know how many last more than 40,000 miles. So as you can see, this does not fall under the standard normal distribution. So we need to take and use this conversion equation to find our z-score. So doing that, we just enter in the equation, or equals x, our 40,000, minus our average, or mu, 36,500, divided by our standard deviation of 5,000. This gives us a z-score of 0.7. So now we want to use that z-score and compute the probability that our tires will last more than 40,000 miles. So we want the area to the right of z equals 0.7. So be careful here, and remember, we want the area to the right, so this is going to be equals 1 minus 1, because the area under the entire curve equals 1. So 1 minus norm.s.dist, and we need our z value, 0.7, comma, true. And we find that the area to the right of z equals 0.7 is 0.2420. Or we could say that 24.2% of our tires will last more than 40,000 miles. So now in our second scenario, we want to know how many tires will last between 37,000 miles and 40,000 miles. So our upper x is 40,000 and our lower x is 37,000. So again, we need to find our z-scores. Now we need to find 2. So equals x minus our mu. That information is all the same. Divided by our standard deviation of 5,000 again. And we need our lower z-score, so equals our lower x, 37,000, minus our mean, 36,500, divided by our 5,000 mile standard deviation, gives us a lower z-score of 0.1. So we want to find the area between these two. So again, equals norm.s.dist, parentheses z, comma, true. So this is the area to the left of 0.7, z equals 0.7. And again, we need to calculate that for our lower z value. And that is 0.5398. So remember, we want what's in between. So we need to take our upper minus our lower. And we get a value of 0.2182, or we could say that 21.82% of tires fall between 37 37,000 and 40,000 miles of use. Okay, so again, what we did here is we took real world information, a normal distribution information, and converted it into standard normal distribution so that we could use our z-values and calculate our probabilities.